Today we are going to cover the topic of time and work. This topic basically involves calculating the time required to finish a job, or the number of people required to finish a work, or the time a person might take to finish a work. So what the general flow of questions on time and work is like, if A takes this time, B takes this, and C takes this, what will be the total time that they take? Or in some cases the total time might be given and we need to back calculate one person's time. These are the basic two types of questions, and other higher level questions just built on these basic concepts. So we basically we'll follow two approaches. We can choose in between any of the two approaches. The first one is LCM approach and the second is the unitary one. So now let's see what these approaches actually mean. The first one that we do is the LCM method. I will explain you both the approaches using one example. So the example is that A takes 10 days to finish a job, B takes 15 days to finish the same job. How long will it take to complete the job if they work together? This is the most basic question, and we'll use this to highlight how the LCM method works. So basically what we need to do is assume the amount of work to be done. We need to quantify the work. So we do that using the LCM of the time taken for them to individually finish the work. Here we'll take the LCM of 10 and 15, which comes down to 30. Now, so we assume the work to be completed to be of 30 units. Now, if A takes 10 days to finish 30 units, his per day work will come to 3 units per day. Similarly, if B takes 15 days to finish the 30 units of work, it will come down to 2 units per day. So together they will finish 3 plus 2, 5 units per day. So now if the total amount of work to be done is 30 units and the per day amount of work completed is 5 units, total time taken to complete the job would be 30 upon 5, which will come down to 6 days. Now we will see how to solve the same question using the unitary method. Here, as the name suggests, unitary, the amount of work to be done will be assumed as 1, and then we'll find the time. So the amount of work to be done is 1. So if A takes 10 days to finish 1, so in 1 day he'll do 1/10 of the work. Similarly for B, he will complete 1/15 of the work. So together again we need to add their individual times. So A plus B will do the work in 1 upon 10 plus 1 upon 15, that comes to 5 upon 30. Simplifying it, it is 1 upon 6. So now the total time, we'll follow the same thing as we used to do in LCM, that is total work upon total work done in 1 day. Since here the total work is 1, we basically follow a shortcut of just reciprocating the job done in 1 day. So 1 upon 6 becomes 6 days. The long way is 1 divided by 1 upon 6. We use this when the fraction of work completed in 1 day is in a different fraction, like it might be 2 upon 3 or 3 upon 5. Then also we can do reciprocal and find the answer will come in fraction, like if it is 2 upon 3, so it will come down to 1 upon 1.5, that is 3 upon 2. So these were the two approaches that we use to solve questions on time and work. There is no hard and fast rule as to which approach you have to use in which question. It is absolutely up to you. You may practice different questions using both the approaches and see which approach you are more comfortable with, and then use that approach moving forward in the higher level questions that will come. So now we will solve a few questions using the two approaches. The first question is, A can do a piece of work in 15 days and B can do it in 30 days. If they work together for 4 days, then what is the fraction of the work left? So let's use the LCM method to finish this question. So here the LCM of 15 and 20 will come to 60. So we assume the total amount of work to be done is 60 units. So for A, If he takes 15 days, his per unit output will come down to 4 units, and for B, per unit output will come to 3 units. So together they finish 7 units in one day. So now the question is asking us if they're working for 4 days. So their total output in 4 days will be 7 into 4, which will come to 28 units. So now to find the fraction of the work left, we need to first find out the number of units left to be completed. That will come down to 32, that is 60 minus 28. So the total fraction of work left will be total amount of work left upon the total amount of work to be completed. That is 32 upon 60. Simplifying it, it comes down to 8 upon 15. Let's move on to the next question. A can do a piece of work in 4 hours, B and C together can do it in 3 hours, while A and C together can do it in 2 hours. How long will B alone take to finish the work? So as I had said in the beginning, that some questions might not give you the data in individual form, but can give you the time taken together. Then you need to back calculate and find the individual time. Here, if you it will be easier if you think about simultaneous equations, where x and y, we have two equations and then we find out individual values by cancelling out. So it is similar to that. Let's see how it's done. So here we're using the unitary method. So A's 1 hour work is 1 upon 4. B plus C's 1 hour work is 1 upon 3. And then A plus C's 1 hour work is 1 upon 2. So now we first find out the total time that they together, all the three together will take. That is A plus B plus C. So that would be if we take A's 1 hour work and B plus C's 1 hour work. That will come down to 1 upon 4 plus 1 upon 3, which is equal to 7 upon 12. Now, from here, if we deduct from A plus B plus C, if we remove A and C, we will get the B's 1 hour worth of work. So how do we do that? We take A plus B plus C's 1 hour work and then we remove A plus C's 1 hour work, that is 7 upon 12 minus 1 upon 12, which comes down to 1 upon 2, which comes down to 1 upon 12. So again, we just do the reciprocal of 1 on 12 and we get that we alone can do the work in 12 hours. So these were the two basic questions. Any other question that comes is just application of the concepts that we have learned here. If you practice an adequate amount of the basic questions, you can use them as a concept and build upon them for your further higher level questions that might come. Thank you.